again, Bruce McConnell here with Locomotive Systems Training. Today we're going to talk about Engine Top Deck, Episode 7, LSTV-007. Well, you know what? Since we've been doing these videos on YouTube, we've actually covered quite a bit of information in a relatively short amount of time. We started out with, let's see, the letter F, and then all the components under the hood, so to speak. Then we kind of broke things down a little bit. And now we talked about the engine, the bare crankcase. Remember, it's not a block. It's a fabricated crankcase. And now we're going to talk about all the components or ingredients that are confined or installed in this crankcase. All right, and we're going to bounce back and forth a little bit, and that's okay. But again, I want to show you what's going on here. All right, this is the top deck. This everything you're standing on the running board out here, okay? And that top deck level, this edge right here is right about here, right about there. So it's a pretty good significant amount of metal below you, also known as the diesel engine. All right, so again, I'm kind of went through it fairly fast the last time we talked about the top deck. I'm going to slow it down a little bit so we can come to a better understanding. So let's start again with this area right in here. This whole area right here, this great big sheet metal component is what they call the top deck or the rim of the engine. It literally encompasses the entire top area, and it goes from like if it's a 16 cylinder, like this one here, this would be the cylinder number 9, because how do I know that? Well, the lay shaft arm is right here going over to the governor. So it literally goes from here, from 9, 10, 11, 12, 13, 14, 15, 16, clear to the end of the engine. Okay, so, and its design purpose is to, number 1, keep dirt and dust out, number 2, to keep the oil in, but also everything that's under this top deck cover is sealed with a seal, and there's actually a vacuum inside this whole area when the engine's running. Not a lot of people know that. But when this engine's running, the top deck cover latches are down, latched, locked, sealed, and the seal and the mating surface is in good condition. You'll actually have a negative or a vacuumous pressure inside here. Okay, so with that being said, let's start up here with this area right in here. These are the camshafts. These EMD engines, these two-stroke engines, all run what they call a dual overhead cam engine. And what does that mean? Dual overhead cam engine, ladies and gentlemen, means the camshaft is above the cylinder head. As you can see, cylinder head's down low here, camshaft is above it. Okay? And when I say dual, there's one on this bank that runs from number 9, assembly clear down to number 16. And on the other side of the exhaust manifold, we have cylinder number 1, all the way down to cylinder number 8. So it's dual cam overhead cam engine. All right. Also, want to let you know that each cam lobe serves a certain purpose. The cam lobes on the exhaust valve, I guess the word I would use would be, I would call them abrupt as far as the trajectory that they have to follow, as opposed to the injector. The injector is a little more roundish, if you will. The exhaust valves are more oval in shape, kind of like an egg. Now, the rocker arm rollers, okay, you have one rocker arm, exhaust valve rocker arm here, you have one injector rocker arm here, and then you have another exhaust valve rocker arm here. Remember from the last video, even though I said that, showed that drawing, that there was 2 exhaust valves, and then I said, whoops, wait a minute. On an EMD, there's actually 4 per cylinder. Here they are, there's 1, 2, and you can't see too well, but 3, 4. 4 exhaust valves in that cylinder head. Now, the exhaust valves open and close based on the action of the camshaft rotating this way, okay, and the rocker arm roller rolling this way, okay. They go just opposite of each other, and it comes down, and as the roller hits the lobe of the cam, and it gets off what they call base circle, which there's no lift or duration, then we begin the opening of these valves. Remember from the last video, ladies and gentlemen, we open these valves at about 103 degrees past top dead center. Remember, the piston's already come up. We've already ignited that fuel air mixture. We're getting that power stroke is going down. And as the piston's going down, we're already starting to open up them valves to relieve that severe amount of pressure, that 2,400 psi pressure in there. Because by the time that piston gets down low enough to the ports, we have to have the air inside the cylinder low enough where we don't get what they call a huge puff back into the exhaust. Otherwise, we're going to have a problem firing that power assembly. So these guys open 103 degrees. They push down, open wide open, drops that pressure from 2,400 down to like next to nothing. And all that gases are sent up through the head, through the exhaust elbow here in the V, open the exhaust manifold forward, or if it's a root blown engine, they'll have exhaust stacks that go straight up. If it's a turbocharged engine, they'll have it where it goes all the way down to the back end of the engine, where it hit the turbine wheel for the turbocharger, and then go out the stack. So those are the camshafts. 2 lobes run exhaust valves, the center one runs an injector lobe. Now, and we're going to talk about this in more detail later, but you notice they all look pretty similar, but yet they're not. Okay, you never ever want to use an exhaust valve in an injector position. Will they fit? Yes, they will fit. What will happen if I use an exhaust valve rocker arm in place of an injector? Well, the injector rocker arm, and you'll see later, has a special notch machined into the bottom side of it that in the event I have an overspeed, that will lock into full fuel position, and that will shut the engine down. No return fuel, no stroke, no fuel, the engine would die. If I put one of these in place of that, I do not have that protection and the engine would still run. That's not a good thing. In fact, if you're doing an overspeed test in this engine and the overspeed trips and the engine still runs, that's an FRA reportable. But because, excuse me, it's an FRA reportable defect because the engine did not completely shut down. All right, so exhaust valve rocker arm, and by the way, the injector rocker arm is a more robust, meaning a lot beefier, a lot stronger rocker arm than the exhaust valve one. And we'll talk about more about that later. All right, sitting where the rocker arm is, right here, we have what they call a valve bridge. The valve bridge does exactly what the name implies. It bridges 2 exhaust valves with 1 rocker arm, okay? Now, we have 1, 2, 3 springs. This is an exhaust valve with a spring. This is an exhaust valve with a spring. And this is a valve bridge with a spring. All right, so a couple neat features I want to run by just real quick on the valve bridge. They're interchangeable with itself. In other words, the valve bridge can be taken off and installed this way, or it can be taken and turned 180 and installed that way. It will work. It'll function just fine. However, for safety reasons, what we do is we orientate the valve bridge. There's a little bitty nub back there. It's cast right into the valve bridge. We always want that facing towards the camshaft. And what that little nub is it's the place where they weld the hole shut after they drill it for the oil passage. Because that's facing forward and that little plug leaks, that well fails, you open that top deck cover, you're going to have oil, hot oil hitting you, and that we don't want that. So we always want to make sure that that little nub right there is always facing towards the camshaft. Now, moving on a little further, we have the rocker arm saddle right here. It's doweled and pinned right here. It's got a hole right here, sits on a pin, and this sits over the stud. Now, remember I mentioned in one of the other videos, I said I'm going to talk to you about what we do, how this upper rocker arm cap, if you will, can fit either way. But if you put it on the wrong way, you tighten this nut down, you will break that cap. You'll actually split it in 2. So what we do is I always tell everybody, there's 2 ways you can do it. Some are marked in or inward for there, but most times all I do, and I tell the people I work with, you put this on, what you do is grab a hold of that saddle, and if it's loose, that's a good thing. If you have that the wrong way and it won't move before you tighten it, you've got it on backwards, and when you tighten it up, you're going to break that. So when you put these saddles on, always make sure you put them on and then they go loose. If they go loose, you're good to go. If they don't move, you're about to build a defect into your power assembly. All right, so we have the saddles, we have the plain washer, and yes, you gotta have a washer under that. You do not want the nut to make contact with this upper saddle, because if you do, you just change the torque on that fastener right there, okay? Now, so you have 2 rocker arm nuts that go over the studs. Have the oil line that comes over here, okay? And that little bad boy, you stop the torque like 7 to 9 pounds, but don't quote me on that. It gets its oil from the camshafts, because the oil runs right down the center of the camshaft. Something else of interest. Oil comes up through this bearing, through the groove, through the hole, down into here, which feeds all the rocker arms, feeds the rocker arm rollers, comes down here, and it feeds oil down here, and especially the injector one, as that oil bounces around there, the oil, the splash lubrication from that injector rocker arm will actually lubricate the injector there, okay? Going down a little further, we have the fuel line. And I did mention this in the last video, but I'm going to tell you again. I have fuel coming in. This is my fuel manifold. Fuel supply is on the top. Fuel return is on the bottom. That's on the manifold. Runs the full length of the engine. Fuel in, bottom line, fuel out. Now, and I mentioned this too. Again, a reminder. Top left, as you're looking at this, top left fuel line in is supply. Bottom right fuel line is return. Okay? Can you put these on backwards? Oh yes, you can. And if you do, that power assembly is not going to work real well because you just changed the flow of the diesel fuel going to that engine or that power assembly. Okay? So you got to make sure you put it on the right way. That's why I gave you that information. This here is our injector rack linkage. It ties into the lay shaft arm here, which has bearings at every location on the crankcase. And a few episodes back, I showed you where these cast areas are that hadn't been machined yet. And here you can see where they actually mount, the lay shaft actually mounts to that machine cast area that gets welded to that. All right, so I have an adjustment nut, I have a lock nut. And guess what? Most people, no, I can't say most, some people out there in the rail industry that are adjusting these are adjusting these wrong. We'll have to talk about that later when we get in the fuel system. Okay, so we have, oh, by the way, also, you need to make sure that when you put this mechanism on right here, this pivot mechanism, that little button is inside the slot of this pivot mechanism. If not, that injector is not going to work and you're going to suffer horsepower loss. Okay, so we have the lay shaft, we have the fuel manifold, we have the fuel line. Let's talk about these nuts right here. 1, 2, 3, 4, 5, 6, 7, 8. These are what we call the head to liner studs and nuts. Again, the same thing applies here. There's a flat washer that goes between the washer and the cylinder head, and they all go into place. And there's a specific torque pattern to torque all these down. Okay, and you got to remember the liner or the piston, the cylinder head and the liner is all connected down right there, down where the cylinder head and the liner meet. But the torque to keep that sealed together and tight and intact is these nuts right here. Okay. Now, speaking of torquing also, we have 4 great big studs. These are what they call in the industry crab studs. I don't know why they call them that, but they do. Anyway, there's crab nuts, and by the way, each one of these has a spherical seat. What that means is it's a dished seat. So if you put one in wrong, you're gonna know it real quick because there's a flat area here, and if you look right here, you can see where it's actually dished out or it's a spherical shape. Okay, make sure you put the right lubricant on these, and you got to make sure you torque these right. And we'll talk about that when we do the class on EMD power assembly installation and removal. Okay, one big thing I am going to tell you though, because if you're out in the field working on this stuff, you got to make sure before you tighten these that each of these crabs is centered equally on each cylinder head. If this crab is turned or twisted where the majority of it's over here and it's a small amount right here, you run the risk of cracking that cylinder head because you don't have enough surface contact between the crab and that cylinder head. The other thing you want to watch for is when you're inspecting this engine, you want to make sure that the crab studs have pretty much the same amount of threads coming through that nut as the other. If you have if it's not enough or it's too much, you might want to look at that as a potential problem. Maybe you have a problem down below the deck where the spherical seat fits for these studs going up through here. Okay. Let me see. Again, we talked about this. You know, the snaps for the top deck cover, the compression release valve or CRV to open up to allow the combustion gas to come out. Head puller holes, cylinder head puller holes are normally full of oil, as they should be. We'll talk about that when we do some troubleshooting, what you look for when you poke those holes out with oil. I think that just about covers, let me take a look back. Yeah, I think we're good. Let's go to the next slide. All right, just a little information here. This here is different views of the cylinder head. Now I want to just show you this because number one, like I mentioned earlier, there are 4 exhaust valves, not 2. Okay, as you can see, they're right there at the bottom of the head. Okay, we also have all these openings right up here. The big holes here is where the liner studs fit in. okay? These little bitty holes here, ladies and gentlemen, is where the cooling water flows from the bottom up. All that heated water from the liner goes into the head through that gasket and seals. Remember we talked about the Teflon heat seal and the seal? Comes up, goes through there, circulates through the head, and then it all comes out right here at this red arrow through the cylinder head discharge elbow. Hottest water right there in that engine is coming out of there. You gotta remember, down below where that power assembly is at full throttle, load 8, the temperature inside that combustion chamber is anywhere between 800 and 1,000 degrees Fahrenheit. So quite a hostile environment when you think about it. Okay, so there's our water outlet elbow there, and also there. 3 different positions of it. 4 exhaust valves. Again, our liner studs, rocker arm studs, exhaust valves. Okay. Oh, by the way, if you use an impact, an air-operated half-inch impact, and you can run your shop any way you want, but I'm here to tell you that if you use an impact on this injector, which sits right here in the center of this hole here, and you use an impact, you're at a very high risk of cracking this cylinder right out here, 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 and here. Because you got to remember, right here in the bottom of this head, right in here, if you were to cut that power assembly in half, and look at it, there's a whole bunch of cooling water in this whole area. So if you over torque that injector, you crack that head, you just built in your own defect. Didn't even know it. Okay, so the right thing to do is install your injector, push the crab bag on it, use a calibrated torque wrench, torque it to 50 foot-pounds, and you're in good shape. Okay, let's go to the next one. Again, we talked about this, but again, it bears repeating. Here's that head elbow, that brass elbow I just showed you. There they are. That's where they go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I ran a little faster, but that's okay. 16 openings. Says right there, 16 each. Water return manifold. Dump that hot air in there. It goes out the front. Okay. All right, let's go to the next one. We mentioned this earlier. Let's talk about it. And by the way, you keep track of my time. When I hit 20 minutes, just let me know.
Okay.
Okay.
You're at 18:30 right now.
Okay. Okay. Remember I was telling you we we're going to talk about rocker arms a little bit. Well, here we go. It's an exhaust valve rocker arm, and this is an injector rocker arm. Looking from top to bottom, there's several small differences. For example, I have a square notch right here where the roller is. Here I have a tapered notch. See that right there? That's one way to identify an exhaust valve rocker arm from an injector rocker arm. But the biggest way is to turn it on its side and look at it. If you look at this, and I'm not to be rude, but let me show you this. See this area right here? Relatively thin in comparison to this. Look at the beefiness of this. Why is that? Why is that so thick? And also this whole area right in here is made much beefier than this. Why is that? Well, the reason for that is this guy has to pump a lot of PSI through that injector, open up in a very hostile environment inside that power assembly, and inject fuel, which takes a lot of pressure. So this guy is subjected to a lot of pressure, a lot of force. That's why the injector rocker arm is so much beefier than the exhaust valve rocker arm. You don't want to mix them up. Remember I told you also back in here we have that little machined area? Well, if you take that, you'll notice that you may not be able to see it here, but there's a machined area back in here. It's a flat that the overspeed trip ball fits in when the overspeed device kicks in. There is no machined area here. So if you use an exhaust valve in lieu of an injector, you just take an overspeed protection of that engine away. Okay, let's go to the next one. Again, there's the rocker arm shaft we talked about earlier. Let's go to the next one. Valve bridge, and we're going to deal with this later. I'm just showing you kind of the oil flow and how the breakdown of this valve is. This is a component that the railroads have been struggling with for years. How do I properly adjust that? And that's something we're going to talk about later on as well. But this just kind of shows you the oil flow. Oil comes in through the rocker arm. Remember we mentioned that earlier. Flows to both sides, comes over to the valve bridge, fills this whole area with fuel, pushes the plunger down. We have zero lash, zero clearance, and the valve operates properly. if we adjust it right. If you're opening that top deck cover and you hear a lot of clacking going on, that's not a good thing. We'll talk about that later. Okay, let's go to the next one. Injectors, there's two different types of injectors. There's an MUI, which is over here, mechanical unit injection. It's got the rack and pinion that opens and closes a helix, which meters fuel either from shut off or idle or notch 1, 2, 3, 4, 5, 6, 7, 8. Then we have the EUI or EFI, electronic fuel injection, or electronic unit injection. You notice it doesn't have a rack here. It actually has two little terminals. That wire from a harness comes in and they connect. They're not polarity sensitive, but you don't put two on one terminal. You put one on each terminal. These are steel braided fuel hoses. This gets that preformed fuel line that I showed you just a little bit ago. We can talk a lot more about that later. Let's go to the next one. Fuel line, now you're in. See, there's that fuel line. This is mechanical. Okay. Remember, you can still put these on backwards. You can turn these back. You can put these on backwards. Total focus, your job is really important, because if you put them on backwards, you just change the flow of fuel going to that injector. It's not going to run right. Mechanical unit injection, electrical. Okay, so what is the next one? Exhaust valves. We're going to talk about this later too. This here is the keepers of it, but also we've got some defects here, cup defects where they're cracked. Why would they crack? Because they're not adjusted properly. Remember what I mentioned a few minutes ago? If you open up that top deck cover and you hear that clack, 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 you have problems in there. That's not a good thing. When you open up that top deck cover, if you know that engine's running right, all you're going to hear is either the blowers running or you're going to hear the turbo whine. That's it. We'll talk about that later as well. All right, let's go to the next one. The injector crab, you can't see, it's buried down in here, but it's kind of like these guys right here. The crab studs are kind of the general shape, only it's kind of U-shaped, but it has a spherical seat in the crab, and also there's a flat washer on one side and a spherical seat on the other side of that flat washer, and there's a plain nut that sits there. You gotta make sure you shove that back when you torque it to 50 foot-pounds, so you're able to get your injector timing tool in there. Okay, so a lot of things we've covered in a very short amount of time. Good information to have. So what I'm going to do is we're going to stop here. Thank you for coming today and watching this. This is cool stuff. You're going to like it more and more as we go along. I want to thank those that are watching it, and for those that are in the industry doing this, work safely. It's also a great resource to come to if you want to learn how to do this stuff the right way and the reason why behind it. That way we reduce road failures and we increase locomotive reliability and availability, which equates to saving money. Remember, go to our website, lst-ca.com. Once again, that's lst-ca.com, and check it out. Thanks, and have a safe day.